This is BSA by Design, a podcast about transforming healthcare, educational, and research facilities through expert design and insight. I'm your host, Brian Moore, and thanks for joining us again. In this episode, I'm joined by Jackie Bieghler and Kevin McNutt to discuss exterior design and how engineering systems play a role in facade design. We also get into some exciting discussion around new materials that are changing the future of exterior design. This is a really fun conversation. And before we get to it, let me briefly introduce our guests on this episode. Jackie Bieghler is a design principal with BSA and has been with the firm since 2007. He has a Bachelor of Architecture from Ball State and is LEED AP certified. Kevin McNutt is an engineering planning principal with BSA. Kevin received his Bachelor of Science in Mechanical Engineering from Olivet Nazarene University. He is licensed PE and has been with BSA for 22 years and served previously as Director of Engineering. Welcome to the show, gentlemen. Thanks for joining me, Jackie and Kevin.
Thank you for having me.
As first-time guests on the show, I always like to ask, where does your passion come from? What made you choose this profession? Jackie, let's start with you.
Well, I'm a bit of an outlier as it relates to this profession. A lot of people over the years that I've talked to within this profession, you know, they had it kind of sunk in them at an early age. I've always been creative and curious, but at the same time, it wasn't until my later years in high school that I was actually had an eye-opening conversation with my high school advisor. And she basically had suggested, you know, have you ever considered architecture? And I did a little bit of exploring, and I thought that would be something that sounds appealing. And after my first year of architecture school, I was hooked. I was just completely ready to dive in with both feet.
And that's why I like to ask the question. Some people are like, I knew it 5 years old. Others, like yourself, have a conversation. Kevin, how about you?
Yeah, so exact opposite. I'm one of those people that didn't really know how I wanted to use my mechanical engineering degree when I graduated. I certainly knew a few things that I didn't want to do based on some of the internships I had and exposure, just, you know, engineering professions that were out there. I know I wanted to focus on design at some level and solving problems within a team. I didn't want to do it by myself. I really like working with teams and building that environment. Ironically, I used to design like my dream house plans when I was a kid. Yeah, I just never thought that I was artistic enough to be an architect. So when I actually landed at BSA, it felt like it was destiny, you know, that I got to help design buildings, but didn't have to be the artsy part of the architect. And it's been a great fit for me ever since.
Did you ever get to use those house plans?
Actually, we renovated our house a couple of years ago, and I designed the floor plan for our renovated house.
That's fantastic. Great. Well, I wanted to have you both on. In many of our episodes, we've talked about the inside of buildings that we design. And I thought it'd be fun to kind of talk about what everyone sees, which is whether you're a user of a building or not. That is, of course, the exterior. So, Jackie, let's start with this. What are some of the key considerations when you're designing an exterior building facade?
Well, there's really four major design influences that I always start with in terms of how those influences would be impacting the building. But those influences are programmatic, contextual, environmental, and budget. Now, each one carries a different weight depending upon the, you know, particular client, particular project. But, you know, just to quickly run down through them, programmatic could be anything from the vision that a client may have, what is the project goal, to brand and identity. What is the exterior perception? What is the sense of place that you're trying to capture and create, form and function? You know, how does the building's exterior relate to what the building is trying to do from a performance and programming standpoint? These are all things that, you know, will directly and indirectly impact just, you know, the influence of the building design. Then we jump into context in terms of site. How is the topography? How is the surrounding building and landscape context actually influence how the building, you know, may be sited and or positioned in how it relates to its surroundings? The visibility, you know, do you want the building to be more discreet and blend in, or do you want it to be bold and stand out in that surrounding context? The circulation with regards to, you know, how the building is accessed from both pedestrian and vehicular interactions, is critical, which will influence that exterior design to some degree. Scale and proportion are all things that will directly impact how that exterior design starts to take shape. And again, leaning into brand and identity and form and function as much as anything else. And then things such as the environmental influences, natural light is a huge one. Just how much daylight and what quality of daylight you can get into a building, as well as the views out from the building, both directly impact how that will impact the building's exterior design. Sustainability considerations and goals, as well as building orientation opportunities, all begin to reflect in the building's exterior design and what significance it may have in that design. And finally, something as simple as budget. Budget is such a significant driver. It's not a easy or fun thing to talk about a lot of times on projects, particularly with clients, but at the same time, it's significantly influencing some opportunities that we explore, study, and eventually implement in a project. That's something that you're just constantly balancing all of these variables and trying to make it work in both functional, creative, and, successful design.
I know we're going to probably dive into a few more of these in specific ways, but let me bring in Kevin here. And Kevin, when I think of engineering, I think a lot of an internal system, and that's just me, of course. But what kind of role does exterior design play from an engineering perspective?
Well, probably the single biggest impact that it has in regards to the selection and the sizing of the HVAC systems. During summer, the envelope design can account for roughly between 20 and 40% of the cooling load required, pending climate, obviously, and building type as well, and double that in winter in some of our climates, certainly, like Indianapolis is quite a bit different than Tampa, but Indy gets pretty cold, and this has a huge impact on our systems. Digging a little bit deeper down, there's two major factors of the design that really impact that HVAC system selection and sizing. The first is the air barrier and how well can you actually seal the envelope construction. A tight building that doesn't leak is certainly an efficient building that keeps the hot summer air out and then the warm indoor air in during the winter. So you're not conditioning all that leakage basically from a loose exterior. The second one is another huge impact is the vision glass. So certainly in the amount and positioning of the windows have a huge impact to the overall efficiency of the building and the HVAC system sizing. We would typically work with an energy model and the architects up front in early design so we can position the building accordingly. We put the windows on the right exposure, basically in improving the efficiency of the system, and then balancing all those things that Jackie talked about with daylighting and the views. So working with the energy model and the architects in early design, certainly to help position the building, also informs the exterior design to look at an overall decrease of the installed HVAC system capacity. We can reduce energy consumption, or we can help hit a target EUI goal that the client might add for their project. Yeah, so thankfully, since I started in this industry, energy codes have put an increased focus on how much the building envelope contributes to the overall energy use, and are really pushing those to increase the efficiency and the better minimum performance of the materials that the architect designed with.
Okay. So, based on both of your answers, there's some definite collaboration between architecture and engineering as it portrays the outside look and feel of the building. And like you said, trying to cut off any leakage and things like that. In what other ways can the exterior envelope contribute to the building's sustainability goals aside from energy efficiency?
Sure. So outside of material selection, which I'll let Jackie talk about that here in a little bit, there are two big things for engineering. One is the vision glass that we talked about. So that performance can certainly lower the energy consumption, but it also provides good views and daylighting. Daylighting is when you can dim your interior lights and take use of natural sunlight coming through the windows. And while daylighting does have energy efficiency impact, I see a larger benefit for the occupants. Just the access to light, the mental health aspects that the natural light provides, it just provides such a better health and wellness perspective when you look at a daylighting in that case in lieu of just energy performance. Right. as people, all of us, we spend a lot of time indoors for work. And so those natural light is certainly something we don't take for granted. So we need to consider that in all of our buildings, especially the healing buildings that we design. The second, that definitely can inform design, but it's more of a construction related activity of envelope commissioning. It can count for LEED credits, which is certainly sustainable. But I think it brings a much larger benefit than just accreditation. It's a third-party review of all the design details that the architects would draft up, and then it's active testing of the installed envelope to make sure that it is performing as we designed. It is a tight building, keeping that infiltration out of the building and really increasing the performance of our systems.
I'll go back with a comment on the daylighting and the impact of lighting. It's been a recurring topic on past episodes, and knowing the time of year that we're recording here in late November, and I've seen nothing but gray for days, my energy level, I feel like since I started BSA, I've learned so much about how light impacts you, even when you hear about it in everyday life, but even being around you guys, it's like, wow, I really need some sunshine. Jackie, can you think of any project examples where the exterior design played a crucial role in the building's performance?
Well, a building's performance, plays a crucial role in every building's exterior design, but the few projects that immediately come to mind are the Purdue's Dudley and Lambertus Hall and the Wake Tech Community College Education and Innovation Center.
Oh, yeah.
Both of those projects promoted various high-performance exterior envelope strategies that significantly improved the building's efficiency. And both projects utilized exterior sun control devices to address both glare and solar heat gain. The Wake Tech building utilized a photovoltaic array on the roof that generates power to help support the building's electrical demand, but it also works to reduce the heat load on the roof so that it provides additional shade for that roof surface so the roof's not sitting there baking in the sun with direct sunlight. Purdue's Dudley and Lambertus Hall maximized, strategically placed expansive window areas to promote natural light penetration deep into the building. That was something that both helped reduce the demand for artificial lighting, as Kevin was mentioning, but at the same time promoted a stronger visual connection both inside and out, which is great for people outside of the building to see activities going on the inside and vice versa. But those were not the only reasons behind the building's exterior design strategies. It's not only important for a building to perform well from an energy usage perspective, but also needs to perform well from an ROI or return on investment perspective. These are things that many of our buildings are, 50 plus year institutional buildings. They're strategically designed to be around for a long time, and it needs a long service life. And some of the design strategies that we implement are intended to enhance and create an environment that performs for those 50 plus years.
And we had, for the listeners, I will harken back to episode 25. We did a case study on the Wake Tech Education Innovation Center if they'd like to listen more, if they haven't checked out that episode. And I'll also drop a link in the show notes to the Purdue, Dudley, and Lambertus Hall project from our website so they can learn a little bit more about that. Those are two great examples. Can either of you discuss the importance of proper detailing in exterior envelope design and its impact on long-term building performance?
Yeah, I'm going to jump in because this is something that I'm pretty passionate about as it relates to how the building envelopes, how we design them. This issue gets into building science, which is one more aspect of building design that we must constantly be conscious of throughout the design process. A building is a complex assembly of materials and systems. These various components, are selected for their specific qualities, whether that's based on aesthetic value, to the composition and or the inherent functional role that they impart in the overall assembly. So our role as designers is to effectively orchestrate how those varied elements are put together into the composition so that it performs well and looks good doing it. It must keep water out, it allow the building to breathe, keep the occupants comfortable throughout the various cycles of the seasons. And don't forget, it needs to do all this staying within the client's budget, which is always a challenging task.
Right. Kevin, anything to add there?
Yeah, so I mentioned envelope commissioning earlier, which is a great feedback loop for the design team, right? That it's reviewed by someone else, it's tested in the field, and all those comments make it back to the designer so we can continually make building better, basically. A good case study on that, we just recently did a building for a large Midwestern university here that they have incorporated envelope commissioning on several of their last projects.
Weird.
And as a result of that, the design continually improved. And the last building that we just opened was the best performing of the 3 or 4, I believe, by far, with all those lessons learned. So we're actually, all this testing on the back end is actually informing a design, and we're all getting better as a result of it.
Yeah, that really is a fantastic feedback loop, like you said. Jackie, you've mentioned materials a few different times. Are there, and I'm going to try not to sound corny here when I say changing the game, but are there some innovative materials or technologies that are changing things up in exterior building design right now?
Yes, there are. Probably
I assumed.
too many to mention. But innovations in architecture, they've been nonstop throughout history. I mean, humans have always found new and creative ways to work technology and materials into the built environment, whether that's being driven by performance enhancements or aesthetic effect.
Yep.
Just in my professional career alone, I've seen significant advances in everything from roofing systems to glazing technology. Even a building material as old as wood has been transformed in recent years from thermal modification processes to improve the wood's durability and resistance to moisture to an engineered wood product like CLT or cross-laminated timber construction systems. We've seen building products be altered to take on their materials' aesthetic qualities while maintaining their own specific performance characteristics, such as metal and composite panels that look like wood but are less affected by environmental conditions. I mean, that's just scratching the surface. And like I said, there's probably too many to go too deep into, but that's just a prime example of how technology is starting to change the way that we look at and think about product selection in building exteriors.
Yeah, you're doing part of my job for me. You're breadcrumbing. There's a question on glazing technology coming in a minute, but go ahead, Kevin. You want to jump in?
Yeah, I was going to mention it relates to the glazing technology. One of the coolest materials I've seen is the vision glass that you can tint by putting an electric current through it. So we had a very large, expansive, western-facing glass for a reading room that we recently did. And so on days like today, where it's overcast in Indiana, that glass can be fully vision and not affect the HVAC sizing. And then on those really bright sunny days where you got that sun coming through, they can dial the electricity up through that glass. They can tint it and not have the issue with increasing the HVAC system load, but still get the vision aspect of it. So they're able to modify the performance of that glass on the fly and still provide a lot of daylighting and a lot of vision for the occupants.
Yes, I'll just go there now. It was something I wanted to talk about later in researching. I'm not the expert here, you guys are, but I try to research and understand what some of the terms that you guys are dealing with. And this glazing technology came up, and I was curious how those advancements are influencing. Jackie, is there anything else to add in terms of glazing technology?
Yeah, absolutely. And Kevin mentioned one, right off the top, that it makes such a huge impact without compromising the effectiveness of what the glass was intended to do. And I'll just run through a few here just to kind of tease the audience. There's a electrically switchable glass, which is similar to what Kevin was just describing, where you literally apply a current and it adjusts the tinting of the glass. It's something that gives the users a controllability, which in today's age, that's what everyone's looking for. They want to be able to manipulate and control, and this is a new technology intended to accommodate that. There's a photochromic glass, which it literally changes from clear to tinted whenever it's exposed to UV light.
Wow.
So it's kind of less control, but it kind of like your sunglasses, they kind of automatically change from inside to outside. That could be applied to glazing on the exterior of a building. A thermochromic glass, which is similar in terms of it changes its opacity level depending upon the temperature. So you can start to get glass that looks more transparent in ideal climatic conditions and less transparent in less than ideal conditions. Now, the one that I find very interesting that I hope becomes more and more prevalent in our industry is a vacuum insulated glass. Basically, what that means is it's insulated glass panels that have a vacuum between the panes of glass. And what it does, it performs 3 to 5 times better than conventional insulated glass from a energy performance standpoint, because there's no air. That medium that transfers heat is lacking in the sandwich. So it helps to promote a more thermally controlled unit. And that's something that it reduces that heat flow, reduces energy cost. And my understanding is it will also improve over time. I don't know if that's incremental small changes or if that would become something that is much more substantial over the life of the glass. But that's something that I think has a lot of promise. So we'll see how that evolves in the coming years.
That is fascinating. I think we probably could do a whole episode probably on glazing technologies, because I find those things very, very interesting. You kind of touched on my next question when you were answering that, but how do you factor in maintenance and longevity when you're selecting materials and systems for the building envelope?
Well, I know Kevin has a few comments here, but one of the things that we're trying to work with is maintenance and longevity. They play such a significant role in our projects. And most of the buildings that we design, they're expected to have that lifespan, like I mentioned, of 50 plus years. So
Right.
As we're evaluating the materials and the assemblies and how everything's kind of put together, we're always mindful of how that material is going to perform. How is it going to last over the next 20, 30, 40, 50 years? And how will it age? How is the anticipated maintenance for the building owner going to be required to keep it up? Are they going to have the capabilities of maintaining that product and those materials over the next 50 years? Or is it going to be a challenge that, is going to be an uphill hill for them to climb? I know one of the things that, we're always trying to be mindful of is trying to design a building that is as maintenance free as it can be, because that's what most clients are looking for, but still kind of has that timeless quality. Because, it's one thing to put up a building that is nearly maintenance free, but it kind of has a dated and maybe cold sensibility to it.
Right.
So those are all things that we try to account for throughout the design process, to be mindful of this, but at the same time, make it easier to maintain rather than more complex and sophisticated to the point where the client just throws up their hands, they don't maintain it, and then the building goes into disrepair and becomes more of a problem than a helpful, environment for them to reside in.
Kevin, do you have anything to add there?
Yeah, so in regards to maybe not like an envelope exterior wall detail, but whether it's exterior equipment versus a screen wall, that certainly impacts the longevity of the system. And Jackie, you mentioned that you want to put in maintenance-free materials, certainly for your exterior envelope. That's not really the case for mechanical. All of our systems certainly need to be maintained all the time. So it's a huge factor in how we would design the system, certainly. So anything that you're putting inside of a screen wall or even exposed, it's going to have a shorter equipment life. It's going to be harder to maintain. You're going to drive up that cost of replacement certainly a lot faster than if you would put it inside. Every project's different, certainly, but I think that's part of the conversation, that first cost could be lower with outdoor equipment and a screen wall. But I've had cases where a penthouse ended up being cheaper with indoor, rated equipment. So certainly a conversation that factors into the maintenance longevity. It's not just the materials in the building, it's all the systems that have to serve the building as well.
It sounds like that constant communication about budget and what might work best and everything. So here's another term I kind of want to ask about, Jackie. Can you explain the concept of active facades and how they might be incorporated into building designs?
Well, this approach to building facade design basically looks to create a responsive design that adapts to the environment and enhances the building's performance. A few of the goals of these design strategies are energy consumption reduction, improved comfort for the building occupants, and generation of renewable energy. Those are 3 ideal factors that directly relate to how active facades can work for a client. Some examples of what those might be could be anything from building integrated voltaics into the building's envelope, which basically means having a photovoltaic skin to the building that's maybe outside of the conventional rooftop panels that you would typically see. Smart facades that utilize responsive technologies that adjust the building's transparency, similar to the glazing options that we talked about earlier, to shading components that actively tilt and adjust as the angle of the sun, moves throughout the day and throughout the seasons. Even a self-cleaning glass, getting back to glass again, glass that has a coating that's literally applied to it that you can see through. You don't see the glass, but with the UV radiation that strikes the glass and rain, it basically helps to shed dirt off of the surface, which means less maintenance for a client. And it's, again, one of those things that's trying to factor in maintenance as well as the aesthetic value of having a surface like that can kind of shed dirt on its own.
Is this an application? Now, I'm going to sound really lame here, but, I see these pop in my Instagram reels for houses where you can put this gel on your windows, and it does similar things. So is this like an application that you put on, or is it purchased kind of already on the glass?
Yes, it's purchased on the glass surface, and it's installed by the manufacturer of the glass system. It's like a coating, but I can't tell you if it's the same product that you've seen advertised or not, because I've seen the same thing, and it kind of makes you wonder if the science is just kind of getting dummied down to a more residential scale.
Yeah. All right. The most marketing question I could think to ask you here, because I care so much about aesthetics as opposed sometimes to, let's say, functionality. So how do you balance aesthetics with functionality when it comes to facade design?
Oh, the art of architecture.
Yes.
Balance is the key word. It's architecture. I mean, it strives to balance art and science within the built environment. And that's something that what we're trying to do is create something that looks good and functions well. And this is an issue that could be driven as much by aesthetics, and which would promote more of an artistic perspective on a building's visual impact. But how the building is crafted, how it's put together, and how it works and performs is informed by the science behind the design. And a building is not only on display, but it influences and is influenced by our environment. And finding that right balance between science of performance and the art of aesthetics is our challenge. I mean, that's what we do every day, and it's something that craft is something that we take great pride in. But at the same time, it's walking that fine line, because it takes both. It can't be all one or the other.
I appreciate your passion on that too. I just wanted to kind of get your input on that as a designer, and I'll bring Kevin back in a little bit for both of you on this next one. This has been fascinating to me, and we kind of referred to it earlier. Kevin, I know you did when you talked about Indianapolis and Tampa, especially given the time of the year that it is, right? So in Tampa, it's probably in the 80s right now. Later this week, we're going to be in the 30s. We've got buildings in Colorado and Texas and North Carolina, all over the place. How do you deal with the regional climate differences and the impact that on your approach to designing building facades?
Jackie, you want to take that one first?
I'm gonna do a little climatic zoning 101 here, okay?
Sure.
The key thing to remember, and Kevin, feel free to weigh in when you have a chance. The primary zones, as far as they relate to climate factors, which are basically components such as temperature, humidity, precipitation, those are all influences to a building's energy performance. And there's 4 primary zones, many of which we touch in our work, some of which we haven't had as significant an opportunity to touch. Of those 4 zones, one being hot, humid, which is typically, in the southeastern states of the country. Cold zones, which are typically northern and midwestern states. You can imagine the upper half of the country, more or less, falls in that category. You've got a mixed humid zone, which is kind of a zone that kind of straddles between Midwest and Southeast, kind of a mix of humidity conditions that you can swing really high during the middle of the summer or really low in the middle of winter. And then the arid zones, which are typically the southwest part of the country, Arizona, New Mexico, Southern California, things like that. But all of those have unique and strategic factors that they're trying to address. High humid zones have higher cooling loads because of that hot humid summer, and so they need very efficient AC systems and shading strategies. Cold zones require a more efficient furnaces and thicker insulation in the walls to help address the heat migration. You get into the mixed zone environment that I was just describing, which many of our offices experience on a more regular basis. We've got swings in both directions. We've got really hot summers that can be really humid and really cold winters that can get really cold. And then obviously arid zones, which we typically aren't doing that much work in, at least as of late, really have what I would call, it's drier, but you get great fluctuations in terms of daytime temperatures and nighttime temperatures. So that's something that has its own nuanced design strategies. Kevin, you want to weigh in?
Yeah, sure. I mean, we're sitting in Indianapolis right now, and I've lived here over 20 years, and I've seen minus 18 and I've seen 102. So I think we're, and maybe not the humidity of a place like Tampa, but certainly we have to combat low humidity in the winter and high humidity in the summer. So quite a good range, certainly, of the different climates that we design in. And the good thing is there's so many technologies out there. There's so many different kinds of systems. We're really more application engineers. We're not designing the equipment that we use, but we're designing the equipment as part of a system that we can tackle all those climate differences between the zones around the country. And so really having the knowledge of working in those areas is the biggest factor that helps us select the right system and then respond basically to the climate and then whatever the architects would like to do from an envelope.
And Kevin, you've touched on natural light earlier. How do you balance the need for natural light with energy efficiency in the facade design?
So I'll say balance is probably a better word than most mechanical engineers would like to use, as compromise. So, there's probably a lot of mechanical engineers out there that would love to do a concrete building with no windows. It's pretty easy to heat and cool. But obviously that's not what's right for the client and the occupants. So balance is the right word. I think the best way to find that balance is energy modeling. So less glass and darker glass is obviously the best for energy performance, but you give up a lot in regards to the ability to daylight, views for the occupants, the natural light that we touched on. So really knowing how all of those decisions impact the overall efficiency of the building, the design, the budget of the building, having those conversations up front with the architects and the client is, in my opinion, the best way to really balance the design of the building and how much glass and where that glass goes to really get the big bang for the buck and the high impact spaces and the
so staying with that and collaboration. Jackie, I wanted to ask, as kind of the project architect or the lead designer on a project, how are you working across disciplines to ensure that the exterior design meets both the architectural vision and also some of these engineering requirements?
I think to Kevin's point, one of the things that we're constantly reminded of and being mindful too is the client's needs. What is their role in the building design, that the criteria that we're striving to meet, and working with the engineers. I'm a strong advocate that having the engineers on the project involved on day one and throughout those early stages of design is critical, because it's helping to establish not only the fundamental design direction, but the inclusion of how the building's going to perform at the very roots of the design process. Because there's things such as orientation of the building, as we've mentioned, the amount of glazing on a project, just the scale and proportion of how much material and what type of construction that we're using that will impact the building performance. And we need to be able to push those levers back and forth to understand a little bit more glass here and a little bit less there could make a major difference in terms of how the building is going to perform. So having those insights and using some of the energy modeling that Kevin was mentioning, I think are key factors into refining the design as soon as possible to get the most effective solution to the client's needs that we can possibly achieve as soon as possible. It all kind of works together. And as Kevin was mentioning, that balance is something that if you get too heavy-handed one way or the other, then the design could start to be compromised, and you don't want that. But at the same time, you want it to be a successful performing building as well as one that looks good.
I was just thinking of, while you were talking timeline there, I can't imagine how not well that would go to be 3 months down the road and have not involved other people, and then to be told, oh, that's not going to work. And so getting the right solution to the client early as possible makes a lot of sense. Kevin, let's do another Brian doesn't know what he's talking about question. In terms of doing some research, I saw this term thermal bridging. Again, I like these terms because I don't know what they mean. I'm a constant learner, so I like to know what is thermal bridging and what role does it play in envelope design, and how do you address it?
Well, I'll do my best to explain it to a non-engineer type then. So to boil it down, it's basically a connection from the building exterior to the interior that allows a higher level of heat transfer that's going to negatively impact the indoor climate. So say it's really cold outside and you have a thermal bridge. If you've ever heard like a no-through metal design, if you have metal touching metal, it's going to conduct that cold from outside and it's going to bring it inside. And so it's not going to be 72 on your interior wall. It could be like 40 on your interior wall. So it's a weakness in the building envelope, basically. So it does two things, really. One, it drives up the energy consumption and the operating costs, which is bad. Secondly, it can lead to condensation both on and inside the interior wall. So that's a larger concern than the increased energy performance. The condensation, I've seen frost on the inside of buildings. Certainly you've opened up an interior wall and you've seen condensation in the wall. Yeah. And we do a lot of humidified buildings. So you got the humidity on the inside, a nice warm atmosphere, and you got that cold leaking in from outside, and it's going to condense there. And honestly, it leads to one of probably the worst words as a building owner that you can hear, and that's mold. So much that people don't even say it a lot of times in our circles. It's very important to design to eliminate thermal bridge.
As we start to wrap up, I've noticed we've spent a lot of time talking about design, and it sounds like they're all new buildings. So for both of you, let's talk a little bit about renovation or retrofit. How do you approach those, renovations or retrofits of an existing building envelope to improve performance? Kevin, why don't you start us off?
Sure. So some states require older buildings to be brought up to the most recent code that they're under. Based on how much of the building is getting renovated. Some states, we don't have a choice. We have to go back through and replace windows, add insulation, add air barriers, whatever the case may be. In the states that don't, it certainly becomes a conversation about the existing performance, the existing comfort of the occupants, and then the energy savings payback that you can get from all those upgrades. So we would typically use an energy model for those conversations and basically price out all the different options that we could do, and then talk about the savings that we could add to that renovation scope and lower their utility bills moving forward for obviously some upfront of building or bringing the building up to code by adding, like I said, adding insulation, applying an air barrier, or replacing the windows if that's needed.
Jackie, how about you?
Everything Kevin touched on are all the things that we'd be doing from an architectural perspective. With the exception of we're trying to be mindful of the context of the project that we're working in. And so whether that's a window fenestration design, trying to emulate what maybe some historically significant design that we want to try to work with, or application of certain systems like Kevin was mentioning, if we're working on a project that has no or very little wall insulation, what can we do in the design to improve the insulative value of that wall without necessarily tearing the entire wall down and redoing it?
Sure.
So those are all things that we would be strategizing on to minimize the impact of what we're going to need to adjust, but still maximize the performance.
I'd like to end by asking future-based questions. So let's look into our crystal ball a little bit. And so this is for both of you. How do you see the field of exterior building design evolving in the next decade, particularly in response to climate change?
Let's see. I probably would circle back to the things that we talked about earlier about all the developments in the materials, the glazing that Jackie mentioned. It's just a balance of cost versus occupant wellness, which has become a great topic in the last 10 years or so. I've been in a lot of what I'll call depressing buildings over the years with little glass, no views. And certainly for a lot of the buildings that we design, we want the exact opposite to be the case. So how can we balance all those great things for occupant wellness and, mental health with not increasing energy performance. So all these materials that Jackie's talking about, the glass that tints, the vacuum sealed glazing, I think that provides a amazing opportunity moving forward to provide, more glass buildings, better views, while not having an impact on the climate. We know that the electrical grids are taxed right now. And so all the buildings that are going to get built in the next 20 years, about all the things that you read, how much the industry is going to grow, we have to find these major things to not let the energy costs just go rampant. So I think it's definitely a balance, and I'm excited to see what materials are coming down the road.
Jackie?
Well, I won't dwell too much in terms of the materials world because it's constantly changing and evolving, and it's kind of hard to put your finger on one thing. But I did want to talk a little bit about construction technology that we're seeing, because I think it will start to make more and more of a splash in our industry. Everything from 3D printing of walls to robotic installation of systems are all becoming a little bit more prevalent year over year. And I think those are all things that will come into play as we start thinking more and more about our designs, whether that's from the construction arm pushing for it and or advocating for it because it might be a more economical solution. Prefabrication is another key feature that I think we're going to see more and more of, and some of our designs will start to try to take advantage of some of those strategies, just because speed is of the essence in most clients' eyes. The faster that they can get their building done, the happier they are. So anything we can do to try to make things more efficient from a deliverable standpoint could work to not only our advantage, but to the client's advantage. So those are things that we'll continue trying to work into our business model, but at the same time, not let it control us. So those are, again, it kind of gets back to that word balance as much as anything. And like I said, building a material research and development is constantly changing. Everything from, like I mentioned earlier, the cross-laminated timber construction world is just exploding right now across the country, to recycled plastics and how those products are getting incorporated more and more into the built environment. Exterior coatings, as we mentioned, everything from the self-cleaning glass to self-cleaning concrete and other skin systems that they are strategically actively interacting with the environment and healing themselves, cleaning themselves. It's almost like a robotic building. So it's going to be constantly evolving throughout our lifetime.
Oh, this has been great. I appreciate you guys joining me. What an awesome conversation about exterior facades and design, both from an architectural and an engineering perspective. I've learned a ton. Hopefully our listeners do too, and hope to have you both back on the show in the future. So thanks for joining me.
Thank you, Brian.
Appreciate it, Brian.
Thanks again to Jackie and Kevin for joining me on this episode of BSA by Design. You can connect with them on LinkedIn. If you're interested in learning more about BSA Life Structures or our design services, we encourage you to visit our website at bsalifestructures.com. There's a link in the show notes to contact us for more information. Be sure to subscribe to BSA by Design on Apple Podcasts, Spotify, and YouTube Music so you don't miss an episode. And we've got more content and project stories to share on social media. So be sure to follow us on LinkedIn, YouTube, Facebook, Instagram, and X. That's going to do it for this episode. Join us again next time on BSA by Design.